When we're designing a building and when we're designing a heating and cooling system, we want to understand the various ways that heat energy can go from hot to cold. And it turns out that there are several different mechanisms and they all can happen in a building at the same time. Conduction, convection, and radiation. They're different, but they're all about transferring heat. Conduction is what happens when materials are touching. So let's say you have a hot stove burner and then you set a pan on the stove burner. That burner and that pan are touching and heat gets conducted through the pan. That is conduction, where the things are touching. The reason that insulation works is because insulation is filled with lots of air, and in air the molecules are not touching each other. They're far apart, and so heat cannot be conducted. There's just a big old air cushion there. Convection is different. Convection is heat transferred through the motion of a fluid, and so that could be a gas or it could be a liquid. For example, if you put your hands over a campfire, heat rises, the hot air rises, that's convection, that warms your hands. Or you could have hot water in a radiant heating system in the floor of a house. That hot water circulating is using convection. And when we think about air causing convection, remember how heat energy is those molecules jumping around, vibrating. And the more they jump around and vibrate, the more they bounce each other farther apart, and so that gas or that liquid is less dense. So it's buoyant, it's lighter weight, and it begins to rise. That's why we have that saying, heat rises. If you are designing a mechanical system, you might also have let's say a furnace or a heat pump with a forced air system. You could cause convection by using a mechanical blower. But natural convection is just caused by heat rising because hotter air is more lightweight. The third method of transferring heat is radiation, and it's different from the other two. Radiation is actually caused by electromagnetic waves going through space, going through the air. And when here's this person down here sitting in front of a space heater. When you sit in front of a space heater, you are not touching that space heater, so it's not conduction, and the air's not really moving, so it's not convection. What is it? It's radiation. Electromagnetic waves are being given off by that heater, and they're reaching you. And if you are colder than the thing that's radiating, you will warm up. Every object in the universe emits electromagnetic radiation, including you. The sun emits electromagnetic radiation, and we call that solar radiation, and these are really just waves coming out from the sun. These waves, these electromagnetic waves that you see in this picture at the top, can be at different lengths. One wavelength happens to be the length of wave that the human eye is designed to detect, so we call that visible light. A little bit longer wavelength is called infrared light. Infrared radiation. A longer yet, microwave radiation, and so forth. So solar radiation comes from the sun, hits the surface of the earth, and some of it bounces back. The greenhouse effect happens when some of these gases in the air block the infrared wavelength, that wavelength, and bounce it back to the surface of the Earth. Well, when you are sitting in a room, you are giving off radiation. That's called terrestrial radiation. And if the objects in your room got heated up, if they're hotter than, let's say, the air or you, they give off terrestrial radiation. And so what building designers know is that we can have air in a room that's, if you measured it with a thermometer, it would seem like that's too cold. But if you have objects in the room that are radiating terrestrial radiation, you'll still feel comfortable. What that means is you don't have to heat all of the air in the room if you can just heat the objects. And so here's a diagram again of what we call the greenhouse effect, these gases in the atmosphere reflecting infrared radiation back to the surface. Actually, radiation is involved in a glass greenhouse as well, but it's a different mechanism. A glass greenhouse actually blocks the infrared radiation and traps it inside. That's slightly different from the blanketing effect of the gases in the atmosphere. But both of them are dealing with infrared radiation.